Top. Donc vous allez présenter en anglais? En anglais. Donc vous allez présenter en anglais. Donc nous vous écoutons. Vous avez 7 minutes? 5 minutes. 5 minutes. C'est bien. Ok, vous avez du matériel en plus. Ok. Ok, ben je vous en prie.
Okay. It's working. Perfect. Hello. Hi everyone. Excuse me. My presentation is going to be in English. My name is Miguel Rodriguez. I come from Spain, from a startup called Cela Medical Solutions. We are a technology-based company that combines different technologies like cloud computing, 3D printing, augmented reality to help surgeons during complex surgeries. So we try to help them to understand the patient anatomy before doing the surgery. And as you know, okay, nowadays, surgical planning is based on direct observation of these images. Yeah, with this technology, still a lot of things have to be guessed. I mean, distances, real volumes, anatomical variance, or the impact of the surgeon decision in the final organ. Yeah. So our company tried to transform these images into not assumptions, but real understanding of the pattern anatomy, trying to avoid the situation when they find something different from what they expect. Yeah. So we try to remove every assumption from the patient anatomy. We try to provide precise information and try to help surgeons to practice before executing in a comprehensive solution. What do? We transform medical imaging, CT, MRI, even echo, into 3D models, and we provide two kinds of solutions. The first one is the virtual model. It's a solution that is provided through internet. You can operate within, and you only need a web browser, no software to be installed. You don't have to buy any software. You can, it works perfectly in any device with a web browser. I mean, a computer, a tablet, or a mobile phone. You can isolate elements, you can take measures, you can know volumes, anatomical variants, and even you can simulate surgery. This solution, it can be applied to a wide range of surgeries, not only for hepatic surgery, and we have different solutions for hepatic, pancreatic, colorectal, urological surgery, and a generic version that can be applied to every surgery. Okay. Its pattern anatomy is different, but at the same time, its treatment is different. So that's why options are different from hepatic, from pancreatic, and the application automatically adapt to the specific kind of surgery. But we try to go further and allow surgeons not only to see the organs they are going to work with. We try to help them to touch the organs through 3D printing, and we can create an exact replica of the organ they are going to operate in opaque material, or even in transparent material. This is a real size organ. This is a liver for a specific surgery, very heavy. Yeah. Very heavy, but with this, surgeons can understand, can approach a surgery very, very precisely and understand how things are going to be in the operating room. Okay. But we can go even further, and we can create those models replicating real tissue physical properties. I mean, they can simulate the surgery because we can create this in material that has the real texture of the organs. They can cut, you can suture, and you can do the surgery, the real surgery before being with a real patient. We have experiences in more than 300 surgeries, and we provide benefits for every stakeholder here. I mean, physicians with better surgical planning, ready-to-use models. You don't have to learn any complicated software. Benefits for patients with better results, better communication, less side effects, and benefits for hospital because you don't need to buy any software. You don't need to buy any machine. We work in what we call a 3D as a service model. It means that surgeons send images to us, and our team transform images in those models that are delivered directly through the hospital. So no capex, no investment needed. Our team is a multidisciplinary team. I'm a co-founder. I'm in charge of the IT part, the technical side of the company, and my partner Dario, who is in charge of the medical side, because the important thing here is not technology, is how surgeons work. That's why we have a medical advisory board who defines the functionalities. I mean, those are tools for surgeons created by surgeons. We collaborate with different research partners, and we have won several mentioned in Spain. Thank you very much. Thank you.
You have some questions for our colleagues about CELA? Yes?
Can we make volumetry by this application?
Volumetries.
Yes.
Yeah. You can see volumetries of every element in the model. Every element is absolutely independent. And for example, for hepatic solution, you can see volumes for every segment. You can see volumes for every tumor, even the interaction of tumors and segments, the interaction of tumors and vessels.
So we can make easily the volumetry? Because we spent much time to make volumetry.
Volumetry is automatically included. Yeah,
Okay.
in every element.
Okay, another questions? No, what about the price and the delay to obtain the models? What is, first, the delay? If I have a patient with a CT scan, I need to send you the CT scan and you build it. What is the delay to have the result for the virtual models and for the real models?
The final price.
No, the delay to have it
The delay.
and the final price.
We need around, our SLA is 4 days.
4
but
days.
If you have any kind of urgency, we can do virtual model in less than 12 hours and even in 4 hours, virtual models. And we can provide this in 4 days.
4 days.
4 days.
Okay. And it is always the same thing with a 3D model. It is rigid 3D models. So I understand that it's possible to do some elastic models.
Yeah.
Yeah. But it is not possible to operate this. It is possible to cut, to try.
Yeah. We create the material with exact same physical properties than the real tissue when you are talking about cutting and suturing. So we try to mimic the effect.
It is not real tissue. I know a little bit.
It's not real tissue. Yeah,
yes.
but we can do this.
Okay.
It's just for demonstration to make it easier to
it's possible to enter it and to try to operate.
Yeah.
It's very interesting this because this is a big issue because there is 3D model but it is rigid and it's not possible to open and to break. And perhaps it's possible to do that. It's really amazing.
Yeah, the time is higher to deliver the final product.
Yeah, what is to obtain non-rigid models? What is the delay and the price?
The price for our non-rigid,
Yeah.
Depend on the size, because, for example, if you are doing a Klatskin tumor,
Yeah.
you don't need the whole parenchyma.
Yeah.
And the price for a simulated texture for this could be around 2,000 euros.
2,000 euros.
2,000
Okay.
euros.
And a rigid?
And a rigid plus the virtual is around 1,000 euros and 800, sorry.
1,000 euros and 1,800 euros. Okay.
Okay.
Thanks a lot. Some question for our colleagues? No? No question? Thanks a lot and congratulations.
Thank you very much. Thank you very much.